So this is OCR's paper 2, foundation tier, non-calculator from November 2019. And if we have a look at your grade boundaries, you need 43 marks for a 4 and 56 marks for a grade 5 on this paper. Question 1, we've just got some nice straightforward addition to do. So we're going to do 89 added to 14 is a non-calculator paper. 9 add 4 is 13. And 8 add 1 is 10. Your answer is 103. Part B, straightforward multiplication. 17 multiplied by 21. We'll use a column method. 1 times 7 is 7, 1 times 1 is 1. Remember, we need a 0 placeholder here. And then we're going to do 2 times 7 is 14. And 2 times 1 is 2. Don't forget to add that 1 there to make 3. And then we just need to add these together. 7 add 0 is 7. 1 add 4 is 5. I've already added that 1. So it's just 357. Question 2, we've got a table showing temperatures from Monday to Friday. And it says, what's the difference between Thursday and Friday? And difference is just about how we get from here to here. It's what's the actual amount between those. So to go from 6 to -3 is a difference of 9. Part B says on Saturday the temperature is 7 degrees higher than on Friday. What is the temperature on Saturday? Well, on Friday it's -3 and we're going 7 degrees higher. 3 of those degrees will get me to 0 and then there'll be 4 left over from the 7. Question 3, we've got some equivalent fraction work. So 2/5 is the same as 4 somethings. On the top there, it looks like we're multiplying by 2. So I'm going to do the same down here. And 5 times 2 is 10. 2/5 is the same as 4/10. I'll write this one out a bit bigger. We've got 2 1/3. And we're trying to change that to thirds only. So mixed number to improper fraction. I'm going to do 2 times 3 is 6. And add that 1 on. Gives me 7. 2 1/3 is 7/3. Part C, we're looking to write this string of multiplications as a single power of 7. Well, we've got 1, 2, 3, 4, 5 7s multiplied together. That's 7 to the power of 5. Question 4, 5/6 of 18. In order to find a fraction of an amount, we're going to divide by this bottom number. So I'm going to do 18 divided by 6. How many 6s in 18? 6, 12, 18. The answer is 3. And then I'm going to multiply by this top number. So take your answer 3. Multiply by 5. 3 5s are 15. Part B, we've got some subtraction to do. We've got £5, take away £1.49. Well, I'm going to write £5 as £5 0 pence. And I'm going to take away £1.49, just making sure that my decimals line up. And we've got decimal, so there's going to be a decimal there. Working downwards, remember, we can't do 0.5 or 0.4, so we need to borrow from here and put a 1 there. And then we're going to need to borrow from there and put a 1 there. Now we've got 10 take 5 is 5. 9 take 4 is also 5. And 4 take 1 is 3. We've got £3.55. And part C, we've got to do 0.15 divided by 5. So there's several ways to do this. I'm going to use a bus stop division. How many 5s into 0.15? 5s into 0 is 0. The decimals will line up. 5s into 1 is 0, remainder 1. And then 5s into 15 is 3. The answer is 0.03. Question 5, just writing 0.3 as a fraction. If you're ever going decimal to fraction, it will be out of 10, 100 or 1,000. And we've just got to see how many digits after the decimal point. If there's one digit after the decimal point I'm looking for the fraction with 1 0. So it would be 3/10. Writing 1/4 as a decimal, some people just know what this is, but if not, see it as a division. You're going to do 1 divided by 4, or how many 4s into 1? 4s into 1 is 0, so we need some decimals and some digits to work with. 4s into 1 is actually 0 remainder 1. 4s into 10, 4, 8, 12, so 4, 8 is 2, with 2 left over. And 4s into 20 is 5. 1/4 is 0.25. Question 6, we've got to write these numbers in order of size, smallest first. If ever you're ordering decimals, just look for your most amount of digits and make sure every number has got that amount of digits after the decimal point. How do we do that? Well, if we're looking for 1, 2, 3 digits, I want 1, 2, 3 digits. 1, 2, 3 digits. 1, 2, 3 digits. Just make them all the same length. And now we've just got to compare what's going on. Clearly, 0.61 is the smallest, and you can write it with the 0 on or just write the original number. These all begin with a 5. So now I'm just going to compare these 3 digits after the decimal point. I think 0.99 is my smallest number. So I've taken care of those two. I've got 900, 977 and 980. I think they're in order as they stand. So I've got 5.9. I've got 5.977. And then I've got 5.98. Question 7, we've just got some fraction work to do. So first question is to add fractions. And we've got to do 1 3/4 added to a half. If you're ever adding fractions or doing anything with fractions, I would never work in mixed numbers. So let's change this to an improper fraction. I'm going to do 1 times 4 is 4. Then add that 3, gives me 7. So that's 7/4, that first fraction. And I'm going to add on a half. If we're ever adding fractions, it's best to get common denominators. You can change these both to 8s. But if I take this fraction and just double the top and double the bottom, 1 times 2 is 2. And 2 times 2 is 4. So this here is the same as 2/4. And I've now got common denominators. 7/4, add 2/4. Well, that's 9/4. Don't change to 8ths. Part B, we've got to do 3/8 divided by 2. Now, if you've got whole numbers, you can write those as fractions as well. That's the same as 3/8 divided by 2 over 1. Your whole number is always just over 1. If you're dividing fractions, you keep the first fraction, you flip the second fraction, just turn it upside down, and you change to a multiply. And multiplying fractions is easy. 3 times 1 is 3, and 8 times 2 is 16. And finally, we've got just multiplying fractions to do, and we've just seen how easy that is. You literally times your tops together. 1 times 1 is 1, and 3 times 2 is 6. My mate Hannah's got some money, and here are the amounts that she's saving every week, and it says find the median. Well, the median we need to put in order, and then it's the middle. So that's what we're going to do. We're going to put these numbers in order. There's an 11 and 11. The next one is 13. Then there's a 22. And the biggest one is 58. And if we just find the middle of those, there's your median, which is 13. Range is just big, take small. So we're going to do 58. Take away 11. And 8 take 1 is 7. 5 take 1 is 6. the range is 67. And part B of this question says in the 6th week, she also saved some money. So we don't know what that final number is. But it says the mean over the 6 weeks is 22. And we need to know how much you saved in this last week. So the mean, well, that comes from add the numbers up and divide by how many numbers there are. And someone's actually done that calculation for us. They've worked out the mean, which is 22. So someone's got the mean is 22, and they've done that by adding up all the amounts that she saved and divided by how many there were. Well, there were 1, 2, 3, 4, 5, 6 numbers there. So something divided by 6 comes to 22. That is the mean calculation. So in order to reverse this, I'm going to do 6 times 22. 6 times 20 is 120, and 6 times 2 is 12. 120 added to 12 is 132. So all these numbers need to add up to 132. Well, what I can do is add these first ones together, and then I'll just see what the last one is by subtracting from 32. So I'm just going to do that mentally. 13 add 58, that would be 71. Add 11 gets 82. Add another 11 is 93. This would be 95. Add 20 is 115. So those first 5 numbers come to 115. I just need to do 132, take away 115, and I'll get this final number there. Work this through, borrow from there, you get 12 take 5 is 7, 2 take 1 is 1, and 1 take 1 is 0. That final number is 17. Question 9, and here we've got some scale drawing to do, and I'm doing this on a phone, so this is going to be a bit rough, but I'll try my best here. What we've got is a scale that says 1 centimetre is 4 kilometres, and we need to know the actual distance between P and Q. So what would you do in your exam? Well, pick up a ruler and measure that distance. You get 5.5 centimetres. So you're going to do 5.5 multiplied by 4. Well, 5 4s are 20, and half of 4 is 2. That comes out at 22, and it'll be 22 kilometres. Part B says measure the bearing of boat Q from P. So from P means we're over here. We're going to get a protractor and just measure this angle there. And when you do that, it comes out anywhere between 63 and 67. So something like 65 is fine. Remember, this is a bearing, so we need 3 digits. It would have to be 065. Part C, we're looking to label where a lighthouse is, and there's a lot going on here. It says the lighthouse is 18 kilometres from here, from P. And I'll start with that. 18 kilometres needs converting back into centimetres. So I need to know how many 4s go into 18. So we can start counting up. 4, 8, 12, 16, and then I need 2 more, and that would be 4.5. There are 4.5 4s into 18. So I need to figure out a point 4.5 centimetres from P. How would you do that? Well, if you've got a compass or a ruler, or both preferably, you'd measure 4.5 centimetres. And if you draw a circle with a radius of 4.5 centimetres, these are all the possible places where the boat could be. But then it says on a bearing of 200 degrees from Q. So what I'm going to do is grab a protractor and measure around 200 degrees, which would be approximately there. And if I draw a line along that point, then where those lines cross is where my boat is. Question 10, we've got a man running at a speed of 5 meters per second and he takes 66 seconds to complete a distance. The horse completes the same distance running at 15 meters per second, and we need to know the difference in times between these two things. So let's start with the man, because I think I've got a bit more information. It says his speed is 5 meters per second and it takes him 66 seconds. So what we can work out here is the distance that he's travelled. So if I know my formula triangle for speed, I've got speed, distance and times. And I want to work out the distance, which is speed times time. So distance equals speed times time. And I'm just going to do 5 times 66. I'm not sure about that, so I'll use a column method. I've got 66 multiplied by 5. 5 times 6 is 30. 5 times 6 is 30. Add on that 3. 33. And then don't forget to bring that 3 down. So my distance is 330 meters. If we now look at the horse runs the same distance, but the speed has changed. So let's write down what we know about the horse. The distance is the same here as the man, so we've got distance equals 330. We know the speed is 15 meters per second. And if I go back to my formula triangle, I can now work out the time. Time is distance divided by speed. So time is going to be distance divided by speed, which is going to be 330 divided by 15. And I'm just going to need to use a column method for this and see how many 15s go into 330. 15s into 3 is 0, remainder 3. 15s into 33 would be 2, remainder 3. Sorry, that's a mess. And 15s into 30 would be 2. So the answer to that is 22. And it would be seconds because it's time. Don't forget to actually answer the question. What's the difference in the times? Well, the man takes 66 seconds. The horse takes 22 seconds. 66 take 22 is 44. Question 11. My mate Alice buys a picture for £180 and sells it for £216, and we want percentage profit. Well, I'll start with profit first. That's just how much money she made. So we're going to do 216, take away 180. 6 take 0 is 6. We can't do 1 take 8, so let's borrow from there. 11 take 8 is 3, and 1 take 1 is 0. She made £36 profit. And if we want percentage profit, we've got to do profit divided by what she started with. So I need to do 36 divided by 180. And then I'm going to multiply by 100 to turn this into a percentage. This is not a very nice calculation, so I'm going to try and find a nicer one. If I half top and bottom, then I can get 18 out of 90. Still not very nice. So again, let's half top and bottom, which is 9 out of 45. These will both divide by 3, which is 3 over 15. And again, these will both divide by 3, which is 1 over 5. I'm getting close to something I can do now, but I've spotted something. If you times this by 20, you will get 100. 5 times 20 is 100, and 1 times 20 is 20, and 20 out of 100 is 20%. And part B of this question, it says, my mate Rashid wants to increase by 17% just using a single decimal multiplier. And we need to know what it is. Well, we always start with 100%. That's important. And if we're increasing by 17%, we're adding 17% on. So altogether, we've got 117%. Percent is out of 100. And this is now just a division. 117 divided by 100 is 1.17. There's your decimal multiplier. Question 12. My mate Adam has got some scores on a paper 1 and a paper 2. And we want to show what percentage was higher. So if we look at paper 1 first. Paper 1, he got 17 out of 20. If we're looking for percentages, then ideally we get this out of 100. So how do you go from 20 to 100? You times 5. We need to do the same on top. So I've got to do 17 times 5. 5 times 10 is 50. 5 times 7 is 35. 50 add 35 is 85. So that's 85% on paper 1. Paper 2, you got 19 out of 25. And again, if we're going to look at percentages, ideally we want this out of 100. So how do we get from 25 to 100? We times 4. And we just need to do the same on top. So I've got to do 19 times 4. 4 times 10 is 40. 4 times 9 is 36. 40 add 36 is 76. And that would be 76%. And that is enough to show that he's got a higher percentage on paper 1 than on paper 2. Part B says the 2 marks are added together and what's the overall percentage for the 2 papers? Well, if we add the scores together, 17 add 19. 9 add 7 is 16, and 1 add 1 add 1 is 3. So he gets 36. Don't forget these are out of different amounts, so we've also got to do 20 added to 25, and that would be 45. So he gets 36 out of 45. And again, we're looking to change this to a percentage. Now, this is not an easy one, but I've spotted these are both in the 9 times table. So if I divide top and bottom by 9, I might get an easier calculation to do. 36 divided by 9 is 4. 45 divided by 9 is 5. And this is much nicer to try and get out of 100. How do you turn 5 into 100? You multiply by 20. So we're going to do the same on the top, times 20, and 4 times 20 is 80, and that is 80%. Question 13, looking to sketch the graph y equals 2. Well, there's y. This is the y-axis, and you can just guess where 2 will be. So y equals 2 is here. We need a straight line going across, not up and down. Y equals 2 goes across in the same direction as the x-axis. Part 2 says sketch the graph of y equals x plus 1. Well, there's some graphs we just need to know, and this is one of them. A straight diagonal line is called y equals x. And y equals x plus 1, we'll just look for 1 on your y-axis and draw this same line, but through that point. So it's like taking y equals x and moving it up by 1. That there is y equals x plus 1. And then part 3 of this question, my mate Kerry says the graphs of y equals 2 and y equals x plus 1 crosses at the point 2, 3. If we look at this point here, y equals 2, this is an x, and this is a y. Whenever you've got coordinates, you've always got an x and a y coordinate, and y is not 2. So I'm thinking she's got her coordinates written the wrong way around. Now part B of this question, we're looking for the graph y equals x squared. Well, if I draw y equals x squared, you'll see exactly what the errors are in this sketch. Okay, that's y equals x squared, and there's clearly 2 errors, so I'm going to write the first one down. It should go through note note. And the second error, it should be a smooth curve. Never join your points together for y equals x squared. Question 14, we've got some ratios and we're just looking to simplify those ratios or write them in simplest form. So this is just like simplifying a fraction. 8 to 10, both sides can be halved. So that would be 4 to 5. And I'm going to stop there because 5 is a prime number. Next question, we've got a slightly more difficult one because we've got mixed units. So we've got litres here, and I need to know that every 1 litre is 1,000 millilitres. So I'm going to do 2.1 times 1,000. Well, 2.1 times 10 would be 21, times 100 would be that, and times 1,000 would be that. So what we get is 300 millilitres to 2,100 millilitres. Straight away we can knock 2 zeros off, which is the same as dividing by 100. And 3 to 21, these are both in the 3 times table, so divide by 3. And divide by 3, 21 divided by 3 is 7. Part B of this question is really tricky. There's no calculator on this paper, so you need to know that the sine of 30 is a half and the tangent of 45 is 1. They're just things that you need to memorise. And we're trying to write this in the form 1 to n. So I want this side to be a 1, and I just need to know what this side is. How do you get from a half to 1? You double. So I'm going to do the same on this side. And 1 times 2 is 2. My ratio is 1 to 2. It actually just wants n, so n equals 2. Question 15, we've got my mate Angie. She's planning a presentation and we've got costs and income. So let's look at the costs first. She's looking to make a small profit. Good news is it says use estimation, which means we're going to do a load of maths but make it as easy as possible. If we've got 10 staff working 6 hours at £8 per hour each, well, I need to do 6 times 8, because that's how much each member of staff is going to earn. So 6 times 8, well, 5 8s are 40, that would be 48. And if I then multiply by 10 because there's 10 staff, that there is what she pays on her staff. Food, well, there's 60 meals at £8.95 each. It says estimate. So I've got 60 meals, each costing not £8.95 but £9. So I just need to do 9 times 60. Well, 9 times 6 is 54. So I'm just going to write 54 and then whack a 0 on the end. And that is what she pays for food. Prizes, there are 12 prizes at £19.99. Well, I'm going to do 12. Not lots of 19.99, but lots of 20. Remember, we're estimating. So 2 12s are 24. And again, just whack a 0 on the end. We can work out her total costs, which is going to be 480 added to 540 added to 240, and that is going to come to note is 8, 12, 16, and then 5, 9, 10, 12. Okay, so she's going to spend £1,260. If we now look at the cash coming in, the income, well, there's 60 guests paying a £5 each. So we're going to get 60 lots of 5. Well, 5 times 6 is 30 with another 0 on the end. And then she's going to get £1,000 sponsorship. So altogether, she's going to get £1,300. That's what she's got coming in. It says she's going to make a small profit. Is she correct? Show your working. The profit she's going to get is 1,300. Take away 1,260. She will make a £40 profit. So yes, she is correct. Question 16, my mate Martina's had a nightmare on this page. She's done a load of algebra, done it all wrong. First question, 2a times a times a is not 4a, it's 2a cubed. A times a times a is the a cubed, and then the 2 at the front. Her error, she added when she should have multiplied. Question 2, what did she do wrong? Well, x to the power of 10 divided by x squared is actually x to the power of 8. We need to do 10 take 2. What she's done is 10 divided by 2. So her error, she should have subtracted 2 from 10, not divided 10 by 2. And question 3 is a bit more challenging. She's got a formula that she's substituting into. We know what U, T and A are. And we just need to see if she's done that right. Well, U is no, that's right. T is 5, that's right. Half is a half. A is 6, that's right. And T is 5, that's right. So all that substitution is correct. If you look here, she's got some squaring to do last. And squaring is indices. And if I write BIDMAS down, this is telling me that indices, the squaring, should always be done first, certainly before multiplying or adding. Okay, so the error there is she should have squared first and then work out the rest. So I'm going to work the actual answer out now. 5 squared is 25. That's the bit we need to do first. We then need to do multiplication. So 0 times 5 is just 0. That's all going to go away. We now need to do 25 times 6 times a half. And that would be the correct answer. Well, 25 times 6. 4 25s are 100. 2 more would be 150. And then we need to do a half of that, which is 75. Question 17, we've got some construction work to do, and we've got 3 bits of information down here. We're looking to plant a tree somewhere, and I'll start with this one because I think it's nicest. At least 50 metres from D. Well, if 5 metres is 1 centimetre, 15 metres is going to be 3 centimetres. Every centimetre is 5 metres. 50 metres is 3 centimetres. So there's D. I'm going to open up my compass to 3 centimetres. And what I'm going to do is a circle with a radius of 3 centimetres. So that's taken care of that bit. This here says closer to CD than to CB. Well, here's CD and here's CB. If I'm going to find closer to one of these lines, what I need to do is cut this angle in half. I need to bisect it. So again, using my compass, I'm just going to draw a circle around C. I'm going to put my compass here and draw this little arc. I'm then going to put my compass here without changing it and draw this little arc. And if I now join those together, I've cut that angle in half. And when it says closer to CD, this side, then CB, I know that this is no good. That's not where my tree is going. This bit says at least 10 meters from AB. So here's AB. I need to be at least 10 meters from this. So again, I'm going to use my compass. 10 meters will be 2 centimeters. Just using this scale above, 10 meters is 2 centimeters. So again, I'm going to open my compass to 2 centimeters and I'm going to draw a little circle around A. I'll go over to B and draw the same circle. And if I connect the tops of those circles, they are all the points 2 centimeters from AB. So my tree needs to be at least 2 centimeters or at least 10 meters from AB. So it can't be in this zone. It can't be in that red zone that I've scrubbed out. And it needs to be at least 15 meters from D. So it can't be in this zone either. My tree can be anywhere in that blank space. Question 18, we've got a quadratic because of these x squared terms, and we're looking to solve it by factorising, meaning we're looking to first put it into 2 brackets. And how do we do that? Well, we want 2 numbers that add together to make 9 and at the same time times to make 20. So just thinking about that number 20, what times us to make it? 1 times 20, 2 times 10, 4 times 5. I'm going to stop there because when you add those together, that comes to 9. And that's what I want to remember. 2 numbers that add to 9, but also times to 20. So these are my key numbers, and they're going to go in my double brackets. It's going to be x add 4 and x add 5. When you've got as far as this and you're then going on to solve the quadratic, well, all you need to do is look at those numbers and change the sign. So rather than +4, we get -4, and rather than +5, we get -5. We've got some information about people on a plane, and it says 2/5 were British, and then it says 30% of the British were men. So I'm just going to write that down, 30% of the British, but wait a minute, 2/5 are British. So I'm going to say 30% of 2/5, they are the British men. If 2/5 are British and 30% of the British are men, 30% of 2/5 are British men. What we've got here is a multiplying fractions question. 30% is 30 out of 100. Well, that's the same as 3 out of 10. Of can be seen as a multiply, and 2/5 is just 2/5. So I've got 3/10 of 2/5. 3 times 2 is 6, and 10 times 5 is 50. So 6/50ths are the British men. We're told that there are 36 British men, so 6/50ths is those 36. Well, 6/50ths is the same as 3/25ths, and that's still 36. I've just simplified my fraction a little bit. If I want to know total number of people, I need 25 25ths. So first I'm going to work out 1/25th, and I'm just going to take this number and divide it by 3. If 3/25ths is 36, 1/25th must be 12. And if I know 1/25th, I can work out 25 25ths. I just need to do 25 times 12. Well, 12 times 25. Well, 10 times 25 is 250. And 2 times 25 is 50. And if you add those together, you get 12 25s, which is 300. And you've got 100 pencils that are either red or green, and it wants a method to estimate the number of pencils without looking and by only picking one pencil at a time. So what you could do is the following. You could pick a pencil and record the colour. You could do that 10 times. And if you get 3 red out of 10, and you're going to do this 100 times, then you would just do 3/10 multiplied by 100, and that would give you 30 pencils. And what we've got is some information about a diagram, and what we're told is AFE, so A to F to E, and CEF, CEF are equilateral triangles, and what that means is all of those sides are the same length. And then it says, what's the mathematical name for AFCE? AFCE, well, that's a 4-sided shape where all the sides are the same. That's a rhombus. It's not a square, it's a pushed over square. Part B says the ratio of angle DAE, so this angle, to EAF, EAF, that angle is 1:4. Well, we know the green angle, EAF, is 60 because that's an equilateral triangle. So if this is 60, then this one must be 60 divided by 4, which is 15. 1:4 as a ratio is the same as 15:60. So that angle there is 15. That means that angle there is 15. And what we can actually say is, what is this entire angle? Well, all of that would be 60, add 15, add 15, which is 90 degrees. Going back into a shape, we already know that this down here is an equilateral triangle. So that would also be 60. 60, 60, 60 makes the 180. Now we've got a 4-sided shape where we know the top and bottom angles. So what I'm going to do is 60 add 90. That equals 150. For a chi, these two angles must be the same. And because this is a 4-sided shape, they all add up to 360. So I'm going to do 360, take away this 150, which is 210. And then because there's 2 of these angles and they're both the same, I'm going to do 210 divided by 2, and that is 105. Question 22, here we've got a Venn diagram, and there's meant to be 100 students in this Venn diagram. Now, if you've ever got a Venn diagram, always check the numbers they've given you. If you take 59, add it to 62, and add it to 20, and see how many students they've given information for, you'll see something. 9 add 2 is 11, and then we've got 5, add 6 is 11, 12, 13, 14. That comes to 141 students, and there's only meant to be 100. You've got 41 too many. If you've ever got too many students, then those extra students always go in the middle of your Venn diagram. They've been double counted, and that's why there's too many altogether. Now we can fill in the rest of the Venn diagram. It says 59 students study history. Well, this is my history circle. It needs to come to 59 altogether. 59, take away the 41 that we've already got. 59 take 41 is 18. Let's look at my geography students. There's meant to be 62 in this circle altogether, and there's 41 of them. So I need to do 62, take 41, and 62 take away 41 is 21. And then this bit at the bottom, 20, not studying any subjects, that's already done. We can just double check that these all add to 100. 18 and 41 is 59. That would be 60, 70, 80. Yeah, makes 100 altogether. Part B says one of the students is selected at random. What's the probability that they study exactly one of the two subjects? Well, it's definitely out of 100 because I'm picking one of these students. And if I want one of the two subjects only, these people, 18, study history only. These people, 21 of them, study geography only. If I add those together, there are 39 students that study just one topic. Question 23, we're looking for an equation of a straight line with gradient of 4. So straight away we know that m, the gradient is 4. We've also got an x, y coordinate. So I'm going to write x equals 1 and y equals 5. And if we take those three pieces of information and substitute into y equals mx plus c, we're going to get the equation of the straight line. Y equals 5, m is 4, and x is 1, and this is a multiplication, so we get 4 times 1. The thing we don't know is c. So we get 5 equals 4 times 1 is 4, plus c. C must equal 1. If we now take our gradient m and the c that we've just found and rewrite y equals mx plus c, we get y equals 4x plus 1. Y equals our mx plus our c.